Hello, everyone. Thank you for joining us today. We are Pittsburgh Java User Group. I'm Sirisha Prata, and I've got Renat over here, who is admitting you all to the session. To learn more about Pittsburgh Java User Group and our upcoming events, you can find information about it on our Meetup page. And if you're a tweeter, you can actually follow our Twitter handle right here. We not only talk about our events, but we also try to tweet information about other Java user groups, other just news around Java in general. So it might just be another useful resource for you to follow. And we've already announced this a couple of times on our sessions this year, but our 2021 and 2022 recordings are up on our Pittsburgh Jug channel. Please subscribe to it so you get notification about it as soon as our recording is up. We are working on our July session. It's a bit out there. It's tentative, especially with all the speakers busy with conferences. It's hard to find speakers exactly for the second Thursday each month. So we will announce it on our Meetup page as soon as we have the session ready. And we would like to thank our official sponsor, JFrog. And with that, I would like to hand it off to Anna. Anna, it's all yours, please. If you could just introduce yourself, and the stage is all yours.
Okay, let me share my screen, and hopefully I can, yeah. Technology nowadays. Okay, so let's get this started. First of all, thank you for having me tonight. Well, this evening and tonight for me, and for adjusting a little bit the schedule to have me over. Very happy to be here with you to introduce you a little bit more about Quarkus and Kubernetes and why these two technologies are great for creating cloud-native Java applications. Just for your record, you can find the slides for this presentation at dn.dev/kubejavafellowship. So if you're going to access this short link, you're going to get the slides. And at the end of the presentation, there's also going to be a QR code with the code that I am going to demo throughout the presentation. So everything, as long as you have the slides, you have everything that you need to look into what I showed today. So a little bit about myself. I'm Anna. I'm a Java champion and certified architect. You can find me on Twitter at Ambra with 2 M's 1508. I'm currently working as a developer advocate for Red Hat, where I like to contribute to different open source technologies, create workshops, deep dives, and many other good stuff that I can share around with different communities such as yours. Pretty much I'm into sharing best practices and working with different Java-based technologies, Kubernetes, OpenShift, and this space, hence the talk of today. So first of all, let's discuss a bit, why do we create cloud-native applications? And let me mute something because I forgot to mute something. Sorry about this. Okay, done. I didn't expect this to be muted. Okay, maybe I'm muted. So now that's all done. Let's get back to the presentation. Why we create the cloud-native applications. So why we need them? Well, throughout time, we realized as developers, as professionals, that we would like to build applications that have architectures open to concurrent changes. And the reason why we wanted to introduce these architectures open to concurrent changes, because we realized that by designing loosely coupled services, we get to have a quicker iterations over features and fixes. So by having microservices, because that's what I'm talking about, like architectures, open to concurrent changes, many applications that can all together work really well, we are able to address changes or fixes much easier. Secondly, these kind of architectures that are open to concurrent changes, they are great in terms of like letting us work with delightful programming models, such as imperative programming. So, and it's great like to do some development with languages and with frameworks that allow you to do this. But not only this, they also support you in like learning them really, really fast. But one of the greatest advantages of going cloud native, and this also from a Java point of view, is the fact that you're not depending anymore on the runtime, because you're pretty much thinking about your application, let's say, as an executable that you would have on your operating system. You don't need necessarily that runtime. So this gets us to packaging our application as lightweight containers. This means less space maybe in the container registries for our builded images. Secondly, when we're having this kind of situations, it's easier to have auto scaling much more efficiently. Meaning, like when we need to upscale, it's easier like to upscale these kind of applications that are starting really, really fast, that are smaller in their size, that are consuming less resources. And also from downscaling perspective, it's easier to downscale them. So these are the greatness of like building architectures open to concurrent changes, but also like going cloud native. But speaking about the Kubernetes native Java universe, what we realized, and probably many of you have seen throughout the different sharing sessions, is by going cloud native with Java, we started like firstly looking into microservices. Then we wanted to have Java going serverless. And also we want to build event-driven architectures. And we needed something to support all these needs of ours as Java developers. And that's where Kubernetes comes into place. Kubernetes can support our need for microservices, can help us into, pondering with and working with the traffic patterns when we add ASTO to it, for example. And from the serverless and event-driven architecture point of view, we're getting this with Knative serving and eventing. So we can go serverless with Knative serving, and we can actually move even more towards the event-driven architecture with Knative eventing. These are some great advantages where Java fits really, really well in the native, in the Kubernetes native world. And since we're talking about Kubernetes native Java and Kubernetes native world, if you're like searching for a proven technology that works with Kubernetes, well, Quarkus is such a technology. For a while, Quarkus includes the Kubernetes extension and the Kubernetes client extension, which enables you to use, fabricate Kubernetes client in native mode. And this makes it easier for you to work with Java applications in Kubernetes. We're going to use that extension today in the demo as well, so you'll see what I'm talking about in a while. But talking about proven technologies and why Quarkus is fitting well with Kubernetes, what happened is that throughout time, some folks realized that they had some challenges when they built their microservices, maybe with different frameworks than Quarkus. And this is such a testimonial coming from a team that built their applications before Quarkus, and they made an assessment of what's going on with them. I put the link to the source in the slides, so you find the link where I have copy pasted this in the slides. And the things that when you're starting to build a distributed platform, your platform will evolve and become much more complex. And at some point, when you're looking and you're taking a step back and looking at what you build, you realize that you have some pain points and you seek to address those. And in this case of this team, for them, their pain points were like setting up the environment, learning the code base when somebody maybe is joining the team, and of course, automating even more. And for them, but for many others as well, adopting Quarkus was a solution. So if you're like wondering how to adopt Quarkus and how to work with it the Kubernetes native way, maybe take the suggestion of this team here, who said that, well, they started with Quarkus within a POC, and afterwards they looked into scaling that. The reason with the POC, why going with the POC is like, well, you're trying to understand how to work with it, but also everybody adjusts to it. And it's much more democratic way of embracing a new framework than just going all in and developing all in with Quarkus, for example. So what is Quarkus? Well, Quarkus is coming from two parts. It's comprised from quark, which is meant for elementary particle, and of course us, which are, well, the hardest thing in computer science, no? So if we're looking to Quarkus, and probably you've seen this before in other presentations about Quarkus, it comes with certain differentiators. And we know, well, it's container first, it's serverless feed, so it's great for having a fast boot time and low RSS memory footprint, can work both with Hotspot and GraalVM. It brings developer joy, and this is very important, especially for that moment when you're setting up things on your computer for the project, or you're like getting code and getting acquainted with code, because it comes with, first of all, live coding, get unified configuration. But starting with Quarkus version 2, you got continuous testing and dev services. So, and we're going to talk about each in detail. Then it's great because you can like code maybe imperative plus reactive, and you have a lot of integrations available with a lot of libraries and standards that are important for us when integrating in the current market. But let's speak about how those differentiators actually impact your work, because they look nice on paper and probably you're wondering, and how is that going to help me in my day-to-day work? Let's start with developer joy, because we have to be feeling great when we're working on something, especially on not so great moments when we're like debugging or trying to fix something or trying to improve performance on something. It's great to have a little developer joy given by the framework, right? So the developer joy of Quarkus comes from the fact that it had made the development and learning it much more easier. Because of the live coding and unified configuration, you're not all the time spending time on restarting any server or something like this. But mostly lately, continuous testing allows you to have consistent testing when you're changing your code. So you're not like worried anymore that your unit tests will fail if you haven't run them specifically. And last but not least, dev services like spare you some time because they offer zero config setup for some of the databases and services such as Kafka, right? So this kind of saves some time for you as a developer in terms of learning or adjusting a certain code base. Now, when it comes to delightful programming models, it's great to have a choice when you are developing an application. So you can choose to go either imperative or reactive if you like to be more close to the event-driven part. And that's a great thing to know, like to have these kind of options and to be able to choose and to test on the spot. Now, from the integration point of view, if you're going to code.quarkus.io, probably you're going to find a lot of integrations available with many popular libraries and standards. And that makes it great for you, like you don't have to all the time spend or invest time on stitching those libraries to your code and keeping two versions all together and compatible. Quarkus takes care of those for you for many of these frameworks or standards. And of course, the most important part when it comes especially to cloud native applications is that we want them to be container first, right? So we want them to be able to dynamically scale up and down quickly. And these are just some numbers about Quarkus, about the fact that it has the reduced memory footprint. So for example, a Quarkus in a native application has like 12 megabytes in like memory footprint, while on JVM it has 73 megabytes because, well, it's running on JVM, while a traditional cloud native stack can grow up to 136 megabytes. Now, not just, memory consumption is low, but you can get also to fast startup time. You can get Quarkus plus in the native mode, you can get to 16 milliseconds, 160 milliseconds, sorry, or in JVM mode, which is closer to 1 second. While a traditional cloud native stack, you probably observe that it takes much more time for it to starting with 4 seconds, and can go even up if you're doing some more initialization things. And of course, a smaller disk footprint that makes it great for scaling up or scaling down. And of course, all the numbers here are being referenced so that you would know where they were gathered, and you can check the facts yourself as well. But let's get to the meaty part of this presentation, because I want to show you a few things about working with Quarkus in the Kubernetes native way. Seeing is believing when working with Quarkus, and it's better for me to show you something like this. But just to give you a quick reminder, with Quarkus, you can go either native with GraalVM or go, the traditional Java way with OpenJDK. So it's up to you how you're going to choose to, in the end, have your application compiled. Where we're going to start to code, of course, at code.quarkus.io, and we're going to add the Kubernetes extension to that one. So if you're wondering what's this line saying here, it's like using the Quarkus CLI in order to add the Kubernetes extension. So let's start to code, and let me go to the browser. Let me see if I can move this thing. Yes, I managed to move it. Great. And let's move this one as well. Now that we got here, let's go to code.quarkus.io and build our application. So we're going to build a friendly message application, and say here org.acme.native. And if I'm remembering correctly, my application, it will be called Fellowship. Okay, I don't want to use Java 11 because, well, it's been for a while in the market. Let's use the latest and the greatest, Java 17. And let's build our application. So starting with Quarkus 2.8, if you're generating your application from here, your generated application is going to go REST Easy Reactive by default. So I will not go with REST Easy Reactive and check it here, but what I would like, I'd like to have, sorry, REST Easy, to have a serialization, which is the JSON-B over that, so over the default. Next, I will interact with the database, which is a Postgres SQL one. So I need a database driver. And because I like writing queries, but throughout time and using Hibernate, I just got used with Hibernate, and would like to use it here as well. And I'd also like to simplify my persistence code with Panache to make it work like that. Because I'm developing something that exposes an API, maybe it would be good to see what I'm going to expose, and just check also the small I open API to document my API and see the Swagger UI present over there. Now we talked about, building the app, but let's see how it can containerize it. So if you're searching for container in the code.quarkus.io, you'll see different options available, like container image build pack, Docker, you can build with Docker, Jib, OpenShift, S2I. So there are a lot of options for you to build a container with when it comes to Quarkus. Well, for this case, I'm going to choose Jib because I would like to build my application Dockerless. Of course, we have to use Kubernetes, right? Because that's what we sell. We're going to use the Kubernetes part. So when typing Kubernetes, what we're going to use is the Quarkus Kubernetes extension that helps us to generate resources from annotations. So it kind of takes away some work from us, like creating YAML by hand, for example. Moreover, what we can do, because we added Kubernetes, it would be great maybe to have some information about the health of our application. So add as well the small I health extension. So that's how I generated the app for today, my my fellowship app, which I have open in my IDE. And let's just look a little bit at my fellowship app. It has a path called welcome. It has a custom greeting. Let me put just Java 17 and start Quarkus in dev mode. Let's just say nvn Quarkus dev. And now that my application is going to start, not sure if you're, well, I'm sure that you're seeing this. The dev services got activated. So you can see here that the dev services are processing information, and they are detecting that they should use the default data source, the Postgres SQL default data source. So even if I don't have anything configured regarding my, connection to a database for my local, that can be spawned up in the background for me so that I don't think about hey, I need access to a Postgres SQL database, so this could work. Moreover, we see that the tests are paused, and let me put them on run. And when I pressed R, what happened is that my tests were run in here by continuous testing. But let me show you something even nicer. Let's go to localhost 8080, go to dev UI. So in dev UI, I have access to all the configurations and ways to like look into more about these configurations. If you like want to access a guide regarding one of the extensions you're using, you can just press on the small icon here and get you to the guide. So like open a new tab and you're getting to the REST services with REST Easy Reactive. So this information can help you like in finding out more what you're building. And moreover, if we're going here, we have our Swagger UI to look at our application. Now that we got this, and also you can see here that all tests are passed. What this is showing is like you can toggle or not toggle the continuous testing even from your browser. This will like be connected to your own application. So it's pretty much the same thing that you were seeing earlier in my IDE. You're seeing it here in the browser as well. It is all connected. Okay, let's do some coding because I talked a lot. We should code a little bit. Okay, so now that we've done this, let me make this a little bit bigger. Let's create a friendly message.java entity. So yes, this is a friendly message Java entity. Let me annotate it with an entity. And of course, maybe put a table and give it its own name. So let me say friendly message. Okay, and here in my friendly message entity, this, I don't want to like preoccupy myself with the primary key. So I'm going to extend the Panache entity for that. And here I would just have some, properties generated on content, language, country, just several strings. We put here generate getters and setters, the usual stuff that you would find in an entity. And voila, we have an entity that we can work with. Furthermore, let's go to our fellowship resource and use this entity that we just created. So I said that, well, we can use Quarkus in the declarative way, right? So let's put a new method and say here on the path all. We don't need any producers like in the case of the above, because this one is going to return a JSON. And by default in Quarkus, if you're not annotating with any produces or consumes, it will be considered that you maybe want to use a JSON. So what do I want? I want to find all. So find all and return. Yeah, maybe on this find all, I need to return a list of friendly messages. Okay, and return friendly message dot list all. Okay, so that easy. Let me just go to my Open API UI, making sure that things are okay here. Try it out. Should return nothing because I inserted nothing in my database, so my method is working. Cool. Let's say make some more stuff. Let's create a few things. So let's do a post. Now, in case of persisting data, we need to annotate this with a transactional. And we're going friendly message, create friendly message. And of course, here we can say friendly message dot persist message and return message. And that would work pretty well for creating. Next, I said we can combine imperative with reactive, right? So let's add some reactive code. Let's make a put and put a new path here for this one. So path. And here, let's use some parameters like language, content. And not only this, okay, maybe on this one, I should like put a little bit of produces. It might be much more helpful. Media type dot application dot JSON. And let's say, oh, this one is also transactional because it interacts with the data and makes some changes on the data. Okay, public. What I'm going to return, uni of integer, and I'm going to explain in a bit what's with the uni. And here I can use, instead of like, you know, query params and all this, I can use at rest path to indicate that this is actually something, is a parameter that I obtained from my path here. So that's how I'm going to make the changes. And here, rest path string content, right? Let's return something and say uni. Now this is how mutiny works. It says like, hey, update something, but from using from an item. So based on the content of this item, and on this item, or do a little transformation. So let me get here to transform. And when you're doing this update of the item, also return to me how many items with this content were updated. So that's pretty much what is going to happen here. Now my query memory is going to be tested. Let's hope I'm remembering correctly. So for when the update where the content is like one, where update content, where language equals true, equals 2, and here content and language. Yep. So that was quite a long journey. So just for recapping, is this part is updating an item content based on the language, and it returns how many of those were updated. So first of all, I think I would like to, you know, insert some data in my application, and I can go here and say my resources and say import -dev.sql, because I want this only for dev, and insert into friendly messages. And here I have my dev configuration, and let me import this one. So let's go again to the browser, execute, and I have some data. And let's make some changes for the French, for the countries where the content is in French, to update the bonjour to salut. Okay, so let me get here, refresh our API, go and try it out. So we want to update salut, where the language is French, and execute. And uh-oh, I have done a mistake. Let me get here. Oh, yeah. Somebody doesn't see pretty well during this time. Okay, let's execute. So now it says that it executed and it updated 2 items. Let's check the items. Let's go to welcome all, try it out, execute again. And you can see now, not for Romania, but for Belgium, you can see salut. For France, you can see salut in French. So it did make the changes in my database. 2 items were updated. Okay, so this is the combining imperative with the active part. How about Kubernetes? Like introduce some Kubernetes to this. Well, to go a little bit the native way, we first need to compile to native, and JIP lets us do this, like compiling to native. And you can even choose and change the base native image in case you're like having upgrades or you have some security patches. You can do this by saying quarkus.jip.base native image and just change it. Moreover, when you are packaging your application, you're building your container image, you can choose where to like push that, build and push that container image using a specific tag. And not sure if, I mean, probably you're wondering what's the UPX7 here, what I said about here. So here's what happens. If you're like really preoccupied about having very, very small container images in the native way, you can like either go with the defaults that are available, or you can even get to an even smaller container image using a compression tool called UPX. Now, if you have on your local or in your pipeline this tool, all you need to add to your Quarkus application is the quarkus.native.compression level so that your container image is going to become even smaller. And let me show you about this in my Ana Sandbox Quay.io. So I'm getting here. Let me just search by name and go to fellowship and show you some differences in that. So if we're going to look to the fellowship in the native mode without any UPX compression level is 34.4 megabytes in size. With UPX 7, I mean like UPX and compression level 7, you can get to 33.9 megabytes. Now, there's a catch with using UPX. It gets you to a smaller container image, but it has a slight increase in the RSS memory footprint. It's not something that is like significant, but you can see that there is a difference with the smaller container image. The reason is because it takes a little memory extra to like uncompress the executable when it runs. So this is the long story short on the container images and the compression level and how it can get even to a smaller one. But let's talk about Kubernetes. So far we don't have much on Kubernetes configured for our microservice here. And there's no Kubernetes part here, just databases and all this. And I would like actually to deploy my application and have it over there in my cluster. So looking here, I have Kubernetes.yaml with some resources already generated, even though that I haven't done any change to my, and I didn't request anything and I didn't put any YAML there. So by default, Quarkus, the Quarkus Kubernetes extension generates this for me, and it can generate also liveness probe and a readiness probe. So all these things just by the definition of the application. But furthermore, if we're looking here, we should add some configurations for our database, which I forgot to create before the session. So we're going to do this a little bit together. So I am not deploying without any database at all. So just quickly creating this in my Red Hat sandbox, click on add database, Postgres, go in Postgres ephemeral, instantiate, and hoping that just by doing this, I'll have a database and everything will work very, very fast for me. So the database is happening here. Okay, hope you'll scale soon. Now, I need this database credentials from here so that I can connect my deployed application, my containerized application when I'm having it here. So I'm going to use the Postgres secret with the database name, password, and user for my application as well. So I need them here, and I need to make Kubernetes aware about this, like to make it aware. And what I can do in this case, I can go here and say Quarkus .kubernetes .env.secrets and say here Postgres, for example. So this one, I'm going to show you in a moment what it generates. Then I can say Quarkus.kubernetes, maybe change the service type and from cluster IP, make it load balancer. And maybe I can expose the application via an ingress. So I can say ingress.expose equals true. While I'm doing this, let me go again to Kubernetes.yaml and see some changes. Well, I should see some changes here. Okay, so now the service is load balancer. Now, if I'm looking to my deployment, it gets the information from the secret that I specified, the Postgres one. And furthermore, it added a new resource called ingress to my fellowship. So let's go to close this one, close the friendly messages. I don't need it so much right now, and get to the command mode. So Java 17, no, I don't need this one. kubectl apply -f and deploy our application, target Kubernetes, kubernetes.yaml. Okay, let's go here and look to our fellowship. Okay, the container is creating, hoping that it will work pretty cool. Okay, so my pod is running. Good. Now that the pod is running and everything's okay, maybe it would be good also to expose my application to external world. So since I am deploying this in OpenShift, I can expose the fellowship that I have here, the service fellowship, by using OC expose SVC fellowship and have an URL to it. And I'm going to display why I'm using the URL, by the way, in a second. So now that this is exposed, I'm going to putting this here. And of course, if I'm going on welcome, if I'm going on all, probably I'll have nothing. So since I'm not having anything, and it would be great like to generate some information, what I'm going to do, I'm going to say export URL and use this part here to export my URL and say chprod_generate.ch and insert some data in my database. So this is why I needed the URL. Now that I'm doing the welcome all, I have some data. And just to be more clarifying, there was another reason why I wanted to do this, is because my application, which is doing some important things, might actually not need the amount of resources that is utilizing right now. So if I'm going on metrics, I'm going to see that my application right now is using 122.6 megabytes, but has requested to Kubernetes, like it would be great, like the upper limit is 750 megabytes, which is quite a lot, like for the upper limit. And of course, it requested for the upper limit one CPU core. Great numbers. But do I really need these? Let's see. So probably the easiest thing to do is like to do a small load test on the application. So let's make a small load test using a tool called Hey. Now this is just experimental for dev purposes. I wouldn't recommend to do load tests with Hey, just to like generate some load. So let's generate 100 requests for 20 concurrent users. And of course we need the URL. So I'm going to use the $URL /welcome/all and make this. So now we have 100 responses, and we should see that there is an increase in requested data. So what we see is a slight increase from 122 to 125 megabytes. Maybe like we should have like put more pressure on this. Yeah, okay, it raised to 135 megabytes. And that's pretty much it. Now, if I'm going to the CPU usage, now the CPU usage increased from 2 millicores to 4 millicores. So not much increase in the CPU either. What I can do, I can go and tailor my application, even from here, from the Quarkus configuration, and say Quarkus Kubernetes resources.limits.cpu. And in this case, for the limits, I don't need more than 200 millicores, I would say, and Quarkus.kubernetes.resources.limits.memory. I wouldn't say that I need more than 280 megabytes for it. So that's pretty much it, because as you saw, under a lot of, let's say, a lot of pressure, the application didn't need much. And let me just copy paste this and use here requests instead of limits. And we're just going to say, okay, for CPU 100 and for memory, I don't think we need more than 140. So just keep it to minimum. Let's go into the Kubernetes.yaml and see what happened with it. So yes, now our Kubernetes.yaml has resources applied. And we just can go to the command mode again. Just select and apply to apply the new resources there. and our application is going to feel fine and great. Let's look again to the Kubernetes.yaml. And if we're looking to the Kubernetes.yaml, we see another resource here. Now, this is typically not generated with the code that I just showed you earlier. So for this, based on this application code, you wouldn't get it. Where did this one came from? It came from a snippet under source main Kubernetes.yaml. So you can append other Kubernetes resources like pod disruption budgets to protect your, for example, in the case of this one, you can protect your deployments, your critical deployment with a pod disruption budget that you specify in the Kubernetes.yaml snippet. What this will do, it will append in the generated Kubernetes.yaml the pod disruption budget. If you're like defining service or deployment or ingress with the same specification as in the generated one, as it would expect in the generated one, what Quarkus is going to do, the extension is going to overwrite that based with what's in the snippet, so it's not going to duplicate. But looking at this kind of YAML, I think it's a little bit risky for us as Java developers to just have this kind of YAML here and not test it. And what I did, I extracted a wrong definition of a pod disruption budget in another YAML to test it using JUnit, well, using unit tests. And what is missing in this one, if you're wondering, is missing the name of the resource. So that one is not present here. And it would be great like to detect this with using Java. The way that we can do this in Java, and especially with Quarkus, is by using the Quarkus test Kubernetes client. So this dependency can help you to test your Kubernetes resources that are not under your generation, you're under your control to generate. So you can just simply go here and create the class. How do I call this one? Pod disruption budget test.java. And you can test this class with some specific changes. So first of all, you need to say to this test, like, hey, I'm going to use a Kubernetes test server. So like annotate it and make it sure that this is like a class that uses a Kubernetes test server. Then make sure that it's a Quarkus test. And the reason why you should do it is because you would like for this one to be taken into account by the continuous testing mechanism. And because this class is, you know, testing things regarding an YAML, which are not what this YAML is needed by our application, but shouldn't be like a deal breaker if this maybe unit test is not okay or is not failing, or it doesn't have any impact on your created native image. So if it doesn't have any impact on your created native image, you can use the disabled on integration test annotation and specify that this type of test should be disabled if the artifact type that is being created is, one sec, for artifact types, disabled on integration test dot artifact type dot native binary. So this, if this is native, and this is like running, it's going to be ran when the native build is being done, don't take this into account because it's not necessarily for that one. And then let's go and you know, create a mock Kubernetes. So let's say Kubernetes test server and say Kubernetes server. So all going Java here, mock Kubernetes. Okay. And let me import this one. Okay. Cool. Now let's go here and say public. Okay, let me make a test method, a test. Okay, public void test pdb from file, because I'm going to test the YAML from a file. And here I'm going to say string path to custom config and put here the path to our custom config, which is source main Kubernetes pdb.yaml. So source main Kubernetes pdb.yaml. Now let's create, because we're in the Java world, we need to create a pod disruption budget Java resource. So let's go here and say pod disruption budget and choose V1. There's also V1 beta, but in Kubernetes, this one was used, like you can check it here in the pdb.yaml. So it's V1, always like make the Java part compatible with what you have in the YAML. So get it here. Next, mock Kubernetes, get client, and on here, get the policy, because it's an object belonging to the policy API. Version 1, of course. Create a pod disruption budget by loading from file, which is at the path custom config. Path to custom config. Custom config. Okay. And of course, get, because you need to get this resource. Let me just put it on another line as well. Next, we should like assert. So I said that that one has a problem. And like maybe you should use like an assert throws on this one and say Kubernetes client exception dot class. So I'm expecting such an exception to be thrown. And again, let's invoke our API. Okay, for this pod disruption budget. And on this one, I can say, well, let me get here. Okay, because it was not going well. Pod disruption budget dot create from the PDB, right? And let me close this part. And of course, I need to import something, import the static throws. And now that I have this one, let me just save everything. And you can see that the tests are passing, all of them, including the pod disruption budget test that was not okay and not feeling well earlier. But now we're talking about Java 17, right? So how else we can test stuff? We can test stuff not with this string YAML, and we add the text blocks. And then we go like this. And we can go here, put the YAML over there. And instead of like having the string to pass to custom config, we can use here in the pod disruption budget, we can use the load from, not the load, but I think it was like create. I don't remember 100%. Yeah, I forgot this one, sorry. And I think I have my test here. So in this case, you find the code over the internet, you can load from the flavored input and you can use the dry run for it. So maybe let me just copy paste this one really, really quick for me. Okay. And run it here as well from this one. And this is the flavored input, but I can put it to YAML and just have the string here. So now that I have some issues, file not found, of course. Import. And of course, come on. Import. Now that I've done this, okay, pod disruption budget test, file not found exception. Okay. That should work. Yeah, it works. Cool. So this is pretty much with the testing part. How about, because we talked about like going native, right? So going a little bit much more, I may be scaling on demand, or going the event-driven way with Knative. How about doing that? Or even going, serverless. So what you can do with Quarkus, you can use an extension called Funky and have your own functions created regardless of your function provider. By just saying here Funky, and I'm going to use the HTTP binding to create my my Funky functions. Let's go to pom.xml and just put the dependency here. Okay, so dependency is obtained. Great. My code is compiling back there, and let's make come on, as we started in dev mode. Let's make a function. So how am I going to make a function really, really quick? I can copy this, I can go here and say paste, and of course rename this and say rename fellowship function.java. Okay, so this is not fellowship resource anymore. We just make a function. Good. We don't need the path because this is going to work with functions. So I'm not pretty much interested in getters or setters. So maybe just what it produces, a text plain. Then what else? This is not get anymore. I need to just annotate with that func. The path, I don't need it. And I'll show you in a moment why. Again, here at func. And here, instead of this one, I just needed func, no more path, and no rest path as well. So probably some of you right now are thinking like, what it should do, why is she doing this, and how am I going to use this? So how I'm going to use this, let me close this few stuff here. Let me split right and close this one. It's okay. So let's make clear and make it bigger. So let's use the functions. How do I invoke these functions? Simple. Curl localhost 8080 /find all, and gets me all the data that I have in my database with find all. Just by using that func, I get the name of a function like directly on the URL with find all. Next, I can say like, well, create and all the other stuff, pretty much similar, and update and everything, just like that. Easy peasy, creating a function using Funky. How about going even more into the serverless paradigm and use Knative? Because so far we have been using a lot of Kubernetes, but how about going Knative? So for Knative to work, you just need to change a few things with your application configuration. So you can use the Quarkus.Kubernetes deployment target and say here Knative, and this will change the context of the generation for your resources to Knative. Then Quarkus.Knative.name, because I want to name the service, and say K fellowship. And then Quarkus.Knative.amp.secrets, because I will also like to have access to the secret as well, like even though I'm deploying this with Knative. So again, Postgres. Let's look at what was generated for us. So you can see here that knative.yaml was generated. And what this contains is a service that will deploy application from a container, having the K fellowship name, having like assistance from the readiness and liveness probe, and it's all Knative generated. Now let's go to the command mode again. Clear. Clear, sorry. And say kubectl apply -f target Kubernetes knative.yaml. So now, if I'm going back here to my topology, where I had my previous application deployed, so I have my Postgres, my application. Let me close this one for a bit. I have my fellowship application being created as a Knative service. And of course, the traffic distribution is being served and being created. Now, the advantage of me deploying this as a Knative service is that when I'm not using my application, then this will scale to 0 automatically. So I'm going here. Okay, it works. Welcome all. So again, the same information, the same data. But if I'm not going to use this for a while, you see that this is downscaling as it is not used. So why should we keep it alive if it's not being used? So efficient resource management just by using Knative. So that was pretty much with a live demo. I just want to give you some last takeaways, like you can empower your local setup with dev services, and that's what I did. I just didn't configure any database in my local, just use the dev services to have my Postgres SQL running. Then I got immediate validation of what was going on with continuous testing, and you saw me coding, and even for the YAML part, I was coding, things were like taken into account and tests were ran. Then I was able to test my Kubernetes YAML with Quarkus test Kubernetes client. So I'm not relying 100% on like me coding correctly the YAML content, but I'm pretty much like also assessing and testing that. Fourthly, I can scale up and down quickly with small container images, and showed you the UPX7, but also you can take advantage of using Knative and the small container image as well. And of course, you can deploy smoothly by combining the generated YAML with your own YAML to protect your application configuration. This is where you can find the code at my GitHub account, umbra/fellowship. So everything that I demoed to you today, it is found there, all the configurations and everything else. And you can try the code on your own as well if you're like wanting to like reproduce it and replicate what I've done. You find it in the repo. And of course, there are some additional resources that you can learn from. The first one, you can get in touch with the Quarkus team on the Zulip chat. And of course, you can like also tag that Quarkus.io, which is great, like to get some traction and to get information, like if it's something burning regarding your Quarkus development, you can get some assistant people, jumping to help you. But you also can get access to and download the ebook of Modernizing Enterprise Java that has samples that are based on Quarkus. And most of the time where I'm getting all the good stuff, including how to add Kubernetes.yaml snippets, is from Quarkus cheat sheet. So there are a lot of good advices with the Quarkus cheat sheet that you probably don't find in the guide yet, but you can complement what's in the guides with the Quarkus cheat sheet. This is pretty much what I wanted to share with you. Thank you very much for your attention, and just wanted to show you that it auto-scaled to 0 when I didn't use my microservice. So again, taking advantage of and like minimizing the resource usage is great. And let's see if there are any questions in the chat. So I just brought the chat here also for me. Okay. Rose, welcome, Rose. Okay. So if anybody has questions, I'm looking forward to them. I'm sure that probably I went to like fast-paced a little bit.
I don't think so. I mean, this was one of the most entertaining presentations ever. Like the demo, the whole thing was just absolutely. I couldn't even tell it was already 7:05. Like, didn't we just start talking? I just feel like I just introduced you and then it's already done. It was beautiful, the entire presentation.
Very interesting.
Thank you. Thank you. Please try the code. Also, if it has any flaws, let me know. But it's what I coded for you today, so I don't think there's going to be much difference.
That's nice. Yeah, I don't see any questions. I think a lot of people are just blown away from the demo itself, so that's a positive sign. I noted down a few things. If nobody else has questions, then I can probably get started maybe. Okay, so the first one was And I don't think I'm imagining this, but you didn't restart the app as you were adding new APIs or as you were doing stuff, right? Like it was...
No. The application is starting. So when I'm writing code, it's reloading the context on itself. The the dev mode is working like this. Just write code and it's reloading things.
Yeah, I did think it was magical like that. So
Nah,
like,
it's not magic. It's not magic.
Am I imagining it? Okay.
No, it's no magic. It's just compiling on the spot. That's it. There's no magic.
Another question that I had was, you had like a small shell script, which was the prod generator.
Yeah.
Is that something that you wrote it or it was auto-generated? I'm not sure if it was.
No, it's something that I wrote it. So
to just load resources, right?
Yeah, because I can do some curls, but it's very easier for me if I'm like just running the curl against an URL and just posting over it. It's checked in as well. I was just making sure that if it's in the repo. So you find it also in the repo. Just export the URL as I did, or just replace the URL, and you can just do the same things as I did to create some data. But this is for a production mode only. The reason being is because in production, I'm probably going to show this. So if like on dev, you're dropping and creating because you don't care, it's dev. On production, you don't drop things. Maybe you'd like to update the data model that you're having. And because you're updating, you're not, creating anything. You cannot use again the SQL load script in production. And I needed to generate some data. So this is why the script there, so that I can have some like really quickly posts done to my endpoints.
That's right. And if it was generated, it would most likely be in the target folder too. Now that I think about it, I just noticed where it was sitting. Yeah. Cool. I'm sort of done. And I think a bunch of like the admin resources and admin tooling that we were getting out of the box was because of the Kubernetes end of things, right? Like the logs and being able to see the resources and how they're being managed.
Pretty much it. Well, I hope I raised your interest in like using combinations like this with Quarkus. I pretty much love the Kubernetes extensions, the Kubernetes one that generates the resources, but also the test dependency, which is also part, by the way. So the test dependency is part of another extension, but I didn't want to add also another dependency to this one as I was not using it. I just added only the test part so that I can make the tests and all this. And give it a try also to Funky. So there's a lot, my colleague Daniel O, he's like really passionate about serverless and Funky, and he has some videos that are quickly explaining how to work with Funky and Knative. And I forgot something. So if you want to test the same things and you're looking for an environment to test things with Knative, just don't struggle on your own, on your local. Just go to developers.redhat.com/developer sandbox and get for free your own sandbox. You just need a Red Hat developer account, which you can easily make.
Nice.
And you get access to this one for free. It's renewable every 30 days, never asking for a credit card or anything. So just get it from there and you replicate everything I did.
Perfect.
Vijay asked the question. I'm reading it right now.
I had a question. I saw that you, everything was different. Like I usually build my REST APIs with Spring and Spring Boot. I didn't see you use any of those REST API calls, right? Like you did everything with Hibernate and Panache. How is that different? Like, can you still customize your application with Spring and Spring Boot as well?
Yes, but I can explain that in a moment. So first of all, I use the REST EZU part, which is specific to Quarkus, and is using the standard Java libraries for creating REST services, the JAX-RS ones. But if you're more used with Spring, you can also use
PC. So everything you had, all the annotations that you had, like where you just simply did like add like get, right? You just had a fellowship resource and
So I
You
pretty
use
much use the JAX or the JavaX, the annotations that are specific to Java, the core Java annotations, nothing specific to a framework. That's what I.
Okay.
But to make a parallel with Spring Boot, if you want to use Spring Boot REST controllers because you're more used to those, or I don't know, Spring Data JPA, because that's the paradigm that you're all the time working with in your day-to-day life.
Spring Boot was easy, right? Like, but whatever you did was was super easy than Spring Boot.
It's Java, the Java way of working.
It's the Java way. So you're using REST API, REST EC reactive. That's what.
Yeah. Yes, it's the REST easy reactive because you get it is the default one generated nowadays from here. So if you don't add anything like I did, I didn't add anything because it was already, adding this one from here. But just for the sake of it is the JAX-RS implementation with the reactive part, and yeah.
It's not like an MVC pattern. It's not like an MVC pattern, like a controller coming in, or
no, because it's not anymore the MVC pattern, because I'm not controlling necessarily the view. I'm just controlling the output, which can be like text plain or JSON. So pretty much like that. So it's not controlling the view, since we're like trying to decouple as much as possible. And just one more thing to add, because probably this part here sounded a little strange. Or looked a little strange. The reason why I introduced this one and I continue to use the reactive extension instead of the regular one is to give you an idea that how easy it is to go reactive and just use the REST paths and all this and feel it as well, not just the traditional ways with the add path and all these other
the add path and add post and everything is all REST easy, the reactive annotations.
Is all REST easy. It's not the reactive way. The thing that is reactive is the REST path. That's it. Because so this is like what you get also in the regular REST easy extensions.
Okay.
But if you're like if you want to use reactive for the multi working with the small reactive way, you get this in the REST easy reactive, the REST path and all this stuff. As I said in the Dev UI, there's this guide. You open it in a new tab, like when you're going to start the application, and you get also the guide, the REST easy reactive, and what is it, and what it brings to the table, and what's the REST path, and all this, and how the representation works, and all this more nicely explained and more in detail than what I did. But there is very good observation and noticing. Thank you.
I know I was using, I think like in today's presentation, I learned about a lot of jargons, like so many other things. Just keep evolving, right? Like as you said, technology nowadays is so hard to keep up. But this, I mean, I thought like I'm a fan of Spring and Spring Boot. And I thought, okay, this was one more option. It's still more easier, like having rather than having an MVC pattern, it's one more option. And yeah, thank you for the wonderful presentation.
Welcome. We have 2 more questions from what I've seen.
Yeah, I was just going to bring them up. Yeah.
So yeah, there's a question about the Hey tool. So Hey tool is an open source tool. I haven't talked to you about it, but I think I documented it in the README. I hope I documented it in the README. You can run the shell. I'm just trying to realize if I documented it. So you can like, did I say something? Run the Hey command tool. No, I don't think I have documented about Hey. So Hey, or we're going to our friend Google, Hey open source tool. Hope that this is working. Yes, this is how you get to Hey. Just Hey open source tool, and you get to it, and it tells you how you can install it. But as I said, this is just for development purposes. It was just for me to like do a small load test on on this system to generate some load. It's not an official load test tool. So don't think it's like something that you can use on production for load testing. It's just for giving you an idea on how the application would behave under a lot of load, and to like really easily bootstrap this in like a few seconds. So yeah, just find it with a Google search and yeah, install it. And it's not big in terms of tool. It is open sourced. Yeah, it's really open source on Apache 2 license. So yeah, that was not documented in the README, but good to notice that one as well. And there's another question about that Srisha also had, like-minded. If the Funky resources are linked here, so are there Funky resources linked here at the dev resources? Like Sirisha or Philip, can you please explain what you're referring to with the Funky resources?
I was just looking for any like documentation, because I thought you mentioned there was someone who was creating these video tutorials. Philip, is that similar to what you were thinking as well? Like just from any place where we can get Funky? Yeah.
Yeah, well, again, Google, Daniel, Funky.
Yeah, same thing. Yeah, looking for any document.
So yes, you can find Quarkus.
Daniel, okay.
Yeah, Daniel is my colleague who's making a lot of presentations on Quarkus Funky, and he's made a lot of great stuff around it. You can find videos about that, but you can also find more on the YouTube. But yeah, he's the main person who's like very passionate about Funky. I'm not remember. Let me check something regarding let me refresh this one a bit. So small rise configuration. I'm also like looking in here if the guide, yeah. So you can see here that also there's a guide with it. It comes with a guide. It's not like it's not documented. So there was also a guide on how to work with Funky HTTP binding. And I think there is another Funky guide or guide to Funky. If you say Funky here, you can find all the documentation available here. So it's Quarkus Funky, what it is, the Amazon Lambdas HTTP, if you love Amazon Lambdas a lot, the Knative events, Azure, Google Cloud. So you can find all these good stuff just by searching in the Quarkus.io guides. And yeah, also they're accompanied with a lot of code, so you can try it. Thank you, Srisha, for pasting.
Yeah, it's just for my own benefit even.
Yeah, just yes.
Yeah, cool. Thank you so much. Thank you so much. This was an awesome presentation. Renat, did you have
yeah, nothing to add, that it was just very awesome. Thank you so much for coming by, Archak.
Thank you for staying up late night for us.
No worries, it was my pleasure to be here, and it was really lovely to meet you all and to finally see you in person. Sirisha, not just talking on Twitter. But it was great to be here. Thank you for inviting me, and I hope that maybe you will invite me some other time and bring some more good stuff. Maybe have some in-person meetups. That would be great as well.
That will be awesome for sure, for us as well. Thank you so much, and we will edit the recording and upload it on YouTube in the next like few days. So, you will hear about it on Twitter and other places. So that's about it. Thank you so much, everyone, for joining us today. And thank you to our speaker, Anna.
Thank you. Bye.
Bye. Good night.
Thank you.